Hi, good day. My name is Mark Bentley and I'm working at the European Space Agency on the BepiColombo mission, and I'd like to talk to you today a little bit about the way that we're using the planetary archives within ESA and some of the lessons that we've learned in trying to make sure that we have valid data when we're using the archive in what we describe as an operational sense. So first I'd like to tell you a little bit about what I mean by that. So in the operational archive concept, what we're doing is we're running the pipelines to generate raw PDS4 products from the telemetry almost immediately after the data hits the ground. So this is done slightly differently for different missions, but in the case where I work on BepiColombo, we run all of the what we call telemetry to raw pipelines, so those that generate raw products based on the telemetry either developed by ourselves at the SOC or developed by the instrument teams and Dockerized. We run those immediately after the end of every ground station pass or on demand as the instruments require. So for example, during a critical phase of the mission, we maybe run those pipelines quite often. And then what we do is we run the technical validation on those products, we package them for delivery to the archive, and then we send them both to the mission repository and also to the Planetary Science Archive. And normally, when public data end up in the PSA, you have access to them via the web view, via the FTP, and via the various APIs that we have. Now, in the case of the data we're delivering soon after reception, of course, this is a bit different because these data are not validated, they're not ready to go public, so these are kept private. So that means that PI teams can access them through the web interface, and they can see the metadata through the APIs that we have, EPN, TAP, and PDAP, but they cannot see the actual data, nor can they be downloaded from the public FTP. So there's a couple of things that are interesting about doing things this way. The first is that we archive very early in the development process, even before we have all of the complete metadata set, sometimes even before the data formats themselves are completely stable. We choose to archive these, but as we say before, these are not made immediately public. So to do this, we start with what we term minimum labels, knowing that they'll change. And that means that we have to have all of the essentials that we need to end up with valid products in the archive. So they have to be valid PDS4 products, they have to accurately describe the files that they produce, they have to pass validation. But we know that they're going to change, and so we tag these with version numbers of less than 1. And then when we have a peer review and we're ready to make these public, we do a little bit of a cleanup and make sure that everything is coherent. So there's a few reasons why we try to do this. The main reason is that this allows us to actively use, or allows the teams to actively use archive data during the mission. It allows us to really do quick look, and Bepi will come back to this later, from the PDS4 products. Now, in terms of validation, this is clearly beneficial because it means that all of our science-based quick look and hopefully all of the science teams doing their science are using these archive products because we've had them ready from the beginning of the mission here. So what we want to avoid is that we have, an archive pipeline generating archive products, which maybe no one looks at and they tick the box and send them to the archive. And we have a separate science pipeline developed by the instrument team, which they do their science on. So we'd of course prefer that this is one pipeline all the way through. And we try to encourage this on Bepi also by making sure that all of the pipeline components, also those generating raw and derived level products, are connected. So that we ask the teams to really make sure that the calibrated pipeline takes as input the raw products. And we enforce this by asking for the teams to deliver these pipelines, even if we are not running them operationally in the SOC, so that we have them also as a redundant backup. So this means that the data products are available very early in the mission. They're available very rapidly, with the teams having to do very little. So as soon as the ground station pass is finished, we trigger the pipelines. We archive the products, and then we have them available for quick look, for science, for monitoring, and we also push copies typically to the teams so that they have them in-house. Also, the fact that they're available early on in the mission is very useful because it allows us to do sort of continuous review and validation of the products as they're generated. Obviously, in flight, conditions change, new experiment modes are used, and every day we see perhaps samples of data we haven't seen before, and so it's useful to get feedback to the teams on how these products are looking, and it's much better than looking at documents. Looking at an ICD is fine and it works, but it's very dry and it's hard to get a flavor of the products if you're not really seeing true science data generated. So this works really well for us to give feedback to the teams about their products and potentially ask for changes. Now, I mentioned this when I gave a similar talk on our operational archive a couple of years ago, but there are some implications on the archive side. And the main thing is that the teams are typically, and we ourselves, are not delivering complete bundles and complete collections. So we are asking the teams to generate pipelines that make products. And these products we then have to, when we ingest them in the PSA has to complete all of the stuff around them. So it has to create or update the bundle and collections and the inventories. It means that we're doing all the validation at either the team side or the SOC side. And it means that the sort of archive level validation, we have to do at the bundle level. And we'll come back to this later. As I mentioned, there is the possibility that we may need to delete data, almost certainly, in fact, for most teams. And also versioning is a bit of a pain. So, we first tried to restrict the versioning to be a very strict, minor number increment with everyone having to be there. But of course, sometimes things go wrong in the pipeline and something is skipped or not generated, or is generated but not ingested. And we had some problems keeping everything in sync. So we've relaxed the requirements for the ingestion of data in the PSA a little bit now to allow minor versions to be skipped. And this is helping a little bit. But still, the versioning when you're delivering potentially new products every hour or few hours in a critical phase, this is quite different from a standard archiving sense. And versioning can be a bit tricky. And the last thing here is that the data, of course, are archived before they're public. So we need to make sure that there is very good access control. And in fact, what we do on these missions is we have a sort of rolling release mechanism. And that's because since users are archiving data on a more or less daily basis, rather than having a batch release, we have this mechanism that tags at the time of ingestion into the database the date that they were hit the PSA, and then based on that we set the release date, after which they will automatically become public. So the technical validation, of course, we use the PDS provided validate tool, which is extremely useful, and it's the first line of defense for everything. And so we're running this on the SOC side and on the instrument team side. And it's a fantastic tool, but we have to be a little bit careful in the operational sense because it is heavily evolving. And this can be due to bug fixes, new features, or changes to the standards. And so because we rely on this tool in an automated sense, we have to be quite careful about managing the upgrades. And this can be because, for example, if we have a bug in our product that is not caught by validate, and then validate is fixed to catch this particular problem, then of course all our products start to fail ingestion and we don't have them in the archive. Conversely, it can be that there is a bug in validate that flags something as invalid when we believe it is valid. So there's a couple of things we have to be careful of here, and we have to test all of the pipelines that are being run very carefully against each new version of validate. The other thing that we can do is that we take the code from the validate tool, which is fantastically available in GitHub, and we wrap this into a product that we call the PDS4 packager. And this takes all of the dictionaries we need and a catalog file, and it bundles this up with validate, adds some extra checks that are not possible within validate itself, and this is what we provide to the teams. And then they run this, and it can do some things like filtering out particular errors or catching some warnings that we believe are not valid or temporarily hiding them. So we do this in order to control slightly better the validation requirements when we go to the teams. The other thing that we need to work on that maybe is not being done so well yet is that we need to check for stale data in our archives. And this can be data after the post-operations phase has ended. And at the moment, we are not doing archive level validation, but this is something we will start very soon. So by this, I mean we're not doing the sort of referential integrity checks to make sure that all of the references are correct in the bundles and collections that we are generating. So we know that this needs to be done, and this is something that's coming on. So one of the things I'd like to talk about is the sort of scientific validation, and the way we can approach this has to be slightly different because of the way that the products are being delivered. So because we're getting the data in small batches of every day, every few days, there are some advantages to this and there are some problems to this. One thing is that we're getting it in very manageable chunks. So it's very easy to load this, to visualize it, and for an operator on a daily basis to say, I've got 10 instruments operating today. I've got this script or this system or this web app or whatever that generates quick look plots based on those data. So it's very easy to eyeball those, and you get very familiar with the type of data that an instrument produces. And so this is something that will be happening in the SOC for BepiColombo, especially during the active mission when we get to Mercury. So that the operators can really take a look and say, yep, that looks fine. I know the typical behavior of this instrument. Oh, that looks fishy. We're not expecting spikes like that. And this is really useful to help us understand whether the data are scientifically valid, whether there's a pipeline bug, whether there's an instrumental problem. So the nice thing is, of course, we're able to do this a lot better with the tools that we have with PDS4 than we could in the past. So software and APIs really help with this. At the moment, we have a limitation in the PSA that the APIs can only access public data. So what we're doing now, as you saw in the diagram early on, is we take the data and ingest it in both the Bepi system and the PSA. And so we run these kind of visualizations based on the data we store in the Bepi side. Now, there are a few things that will help this. One of them is the Data Labs project, which you can see in talk or abstract 7014. And on Bepi, we've invested in a separate quick look analysis system using these local generated copies. So these tools make things a lot easier. We can use Jupyter Notebooks, for example, to do the validation. But as I mentioned, we have this quick look analysis system on Bepi. So the way we do this is first we kind of prototype data in JupyterLabs. And here's an example. It's very simple once we have the tools in place to plot the data. And so this is used obviously for first level validation. And this is how we on Bepi prototype the visualizations we want for the quick look analysis system. So these JupyterLabs, I think this is a really great way of moving forward. These self-documenting tutorials that we can write are fantastic. And we're also asking the teams to provide these notebooks as tutorials for future archive users. And eventually we'll move forward and ask them to provide examples of how to calibrate raw to calibrated data. So this is something that I think will really help in the future users to get a handle on the data. But for Bepi, we have, as I mentioned, this quick look analysis system. And in this system, it's a web app which takes the raw PDS4 products. I don't mean here raw as in the calibrated level, but simply it takes the actual PDS4 products. We're not storing them in a database or anything. And it reads the data that's requested for a given time range and plots them as the teams have requested these data to be plotted. So this means we get a really good scientific use case in the QLA where users can come in and see the data transformed into the form they really want to use for science. So it's a really excellent way of validating on a daily basis these products. It's also useful for sanity checking. I mean, a few times we've caught things where the data have really, something has been wrong. In this case, it turned out to be a pipeline bug on our side. There was a large jump in the magnetic field measured, and it was obviously completely unphysical. And then you look at the data and you see there's a clear issue here that needed to be resolved. And then we could find that very easily. And the other thing we're doing is something called the Science Analysis Forum. And this is using Discourse, a forum which you may have come across on the internet. And we're integrating this very tightly with the quick look analysis system so that when the users themselves see something that is either interesting or odd, they can click on the plot or the image or the spectrum, and this will automatically generate a post in Discourse along with a lot of custom metadata about the time and the spatial coordinates of those data. And it will then raise a forum post where other users can comment and discuss this. So it's a great way to capture discussions about the science and about the technical validity of the data. And also, I think at the end, we can use this to feed back into the archive lists of interesting events. And of course, at the end, the more eyes on the data, the better the chances of validation. So this is something how it'll look. We'll click a button in the plot. It will copy the particular image that you see in the quick look into a forum post. It will generate these metadata and store them in the back end to allow for search and retrieval later. And then, of course, the discussion can continue from there. So the PSA obviously is a multi-mission archive. It contains mission data from many missions, many instruments, and it cannot really support the detailed visualization of all the data. So when we're doing this when we're doing this operational archiving, we cannot visualize all these data in the PSA because it would just be too demanding. So on the Bepi side, we have this quick look analysis tool, which is great, but it may not be feasible for all missions. But I think we can move forward with something a little more generic. So we have a lot of tools these days to work with PDS4, which we can use for visualization, for validation. On the PSA side, we need to add a little bit of glue, some libraries, better APIs to bring this all together so that in the future, other missions using this operational archiving approach can take advantage of these tools to really do very quick, rapid, on-the-fly validation of the data. So in summary, the operational use of an archive is super. It allows you to develop the archive data formats very early in the mission. It allows you to do validation of the data formats very early on. And of course, regular eyes-on allows us to do human validation of these data. We need to take care because of the multiple versions in the archive, some of which can be incomplete due to the nature of our running the pipelines. But we at the end have a great set of tools to dig into that data, and we just need to put a little more work on gluing some of these together so that moving forward we can use this approach for all of our archives. I thank you for your time, and I'll take any questions in the appropriate forum. Thanks a lot.